dividing and simplifying radicals. What you need to know in this section is symmetric to what you needed to know in the previous section. The previous section, we used the fact that the square root of AB is the square root of A times the square root of B. Well, now if you have a fraction, the square root of A over B, this is the square root of A divided by the square root of B. And the second one, that's what we're going to use in this section, hence the title, dividing by radicals. Now, sometimes you don't really want to do this step up here. The reason is I know what 36 divided by 4 is. It's 9, and I know the square root of 9. Now, of course, in this case, in the problem we just did, if you did separate them, it would have been okay because you know the square root of 36, you know the square root of 2. Excuse me, the square root of 4 is 2. And 6 divided by 2 is 3. But now, what if you had 75 over 3? If you simplify it, that is, if you do the division first, you get 25, and you say, oh, I know that one. Square root of 25 is 5. But if you use this rule, and trying to hint, it's not always good to use the rule. If you say that's the square root of 75 over the square root of 3, I would say yes it is. But it wasn't that helpful. 75, the largest number that goes into 75 that I know the square root of is 25. 25 times 3. The radical 3's cancel out. We're left with just the square root of 25, which is 5. Of course, the same answer as before. But look at the little work I did here. Look at all the work I did down here. Sometimes it pays to do the division first. Other times it pays not to do the division first. If you have the square root of 4 over 25, and you say, ooh, I know the square root of 4, and I know the square root of 25. I would separate this. Now, whether you write this step or not, you have to think it. The square root of 4 is 2. The square root of 25 is 5. Or the square root of 4 is 2, and the square root of 25 is 5. You have to think that, oh, I can take the square roots separately. I can use the square root of the numerator and divide that by the square root of the denominator. In this case, it definitely paid off to separate it. Besides, you couldn't reduce 4 over 25 anyways. Now, if you have the square root of 3 over the square root of 27, you can realize that as the square root is 3 over 27. But this can be reduced to 1/9. 3 goes into 3 one time. 3 goes into the bottom number 9 times. The square root of 1 is 1. The square root of 9 is 3. And this is 1/3. If you have the cube root of e cubed over 64, well, this is the cube root of e cubed divided by the cube root of 64. This is asking, the numerator is asking, what times itself 3 times gives me e cubed? What times itself 3 times? Now remember, e cubed is e times e times e. So what times itself 3 times gives me this? Well, the answer is right there. It's e. E times itself 3 times gives me e cubed. Bottom. What times itself 3 times gives me 64? Well, 3 times 3 times 3 is 27, but 4 times 4 times 4 is 64. Keep in mind that 64 is 4 cubed. What times itself 3 times gives me 4 cubed? 4. What times itself 3 times gives me 64? 4. So it's e over 4. Sometimes you separate, sometimes you don't separate. And very similar problem to the last one. You have e to the 5. 2 times e to the 5 over 128 e squared. I don't know the cube root of the numerator. I don't know the cube root of the denominator. But I'm going to simplify. 2 goes into 128 64 times. E squared goes into e to the 5th e cubed times. I know this one, we just did it, it's e over 4. Sometimes you reduce and then you separate. You do enough for these, you learn what the technique is. Now, remember, the square root of a number times the square root of a number, which, by the way, is shorthand for this, is just that number. If you have it 2 times, you get what's underneath the radical. So if x were 5, the square root of 5 times the square root of 5 is simply 5. Now, the third root of x times the third root of x times the third root of x. Powers are 3. You need it 3 times to get back x. The 5th root of y, y squared, the 5th root of y squared times the 5th root of y squared times the 5th root of y squared times the 5th root of y squared. We have it 1, 2, 3, 4, 5. So we get back what's underneath the radical sign. They need all to be 5. You multiply the 5th root of anything by itself 5 times, you get back to anything. You definitely know that. Okay, now, final answers. I mentioned this a little bit earlier in passing. Final answers should not have radicals in the denominator. Instructions are to simplify. So you have 1 over the square root of 5. It's not simplified because there's a radical in the bottom. So I want to change the way this looks. If you're going to learn one thing watching this video, I want you to learn that if you want to change the way something looks, that means you want to multiply by 1. There's many ways of writing 1. 7 over 7 is equal to 1. 2/3 divided by 2/3 is 1. -8 divided by -8 is 1. These all equal 1. As long as the top and the bottom are the same, it's 1. With one exception, 0 over 0, top and bottom are the same, but it's not 1. Now, my goal is, when I write the 1, is that the square root of 5 times what I put there gives me a number without a radical sign. And square root of 5 times square root of 5 gives me a number without a radical sign. Now, students look elsewhere. They look outside these brackets to decide what goes in the numerator. A fraction is 1 only when the bottom and the top are the same, and they're not 0. Square root of 5 is not 0. So it's square root of 5 over square root of 5. That's my 1. 1 times square root of 5 is square root of 5. And there it is. I mean, 1/5 surely equals itself times 1. Square root of 5 over square root of 5 is 1. 1 over square root of 5 times 1, it definitely equals square root of 5. And it also equals square root of 5 over 5. So you got 3 over the square root of 3. Well, there's 2 ways of doing this. This is probably the least popular way for students. 3 is square root of 3 times square root of 3. That's what 3 equals. Just like 5 equals square root of 5 times square root of 5. Divided by square root of 3, you get the square root of 3. That's one way of doing this problem. And though it's least popular, the easier of the 2 methods. The other method is to multiply by 1. It equals itself times 1. And usually that 1 will be a fraction. I don't know why that didn't come out. Okay. Square root of 3 times square root of 3 gives me a number without a radical. If square root of 3 is on the bottom, and what's in the bracket should equal 1, come on, put square root of 3 on top. 3 times square root of 3 is 3 square root of 3. The 3 is reduced to 1. 1 radical of 3 is radical of 3. Now, it took an extra line. Here I had 1, 2, 3 statements. The first one being the original statement. 2, 3, 4. Here's one extra computation. But that's the more popular way, and that also gets you the right answer. What if you have the square root of RS? Change that. Square root of R divided by square root of S. Square root of R divided by square root of S. Well, as always, we want to change the way it looks because we don't want radicals in the bottom. So it equals itself times 1. I'm going to put square root of S on the bottom because when I multiply, I just get S. So I have to put square root of S on top. Square root of R times square root of S. The square root of one thing times the square root of another thing is the square root of their product. R times S is RS. Try another one. Suppose you have 4 over the cube root of 5, which of course equals itself, times 1. Now, if you have square root of cube root of 5, and you want to get a real number, well, that's not true. You want to get an integer, you need cube root of 5 3 times. But since you have it 1 time, you need it 2 more times. So cube root of 5 times cube root of 5 times cube root of 5 is 5. On the top, you have to put the same thing you put on the bottom. But I'll just write it down with 1 cube root sign. 5 times 5 is 25. So it's 4 times that. 4 times the cube root of 25 divided by 5. You should try to reduce. If the 4 were a 10 instead, then 5 would go into it. Now, here's a tricky one, especially when the numbers are very big. Right? If you have the 4th root of 8 in the bottom. Now, there are 2 ways of doing this. There are 2 ways of doing this. Hard way, easy way. You need 4th root of 8 4 times. We have it 1, so you need it 3 more times. You need it 3 more times. And on the top, 8 times 8 is 64, times another 8, looks like 512. The 4th root of 512. Okay, so you get 3 times the 4th root of 512 divided by 8. Divided by 8. Now, I'm going to come back to this one because I don't know real quickly how to break that up. But there's a lot more work to be done here. Now, if instead we realized that 8 is 2 times 2 times 2, this is the 4th root of 2 times the 4th root of 2 times the 4th root of 2. I want to multiply that by 1. Well, I need this 4 times. I need the 4th root of 2 4 times. I have it 3 times. I need it one more time. 3 times 4 is 12 times the square root of 2. Oh, excuse me. That's not our 4. That's the 4th root, excuse me. So we have 3 4th root times the 4th root of 2. 3 times the 4th root of 2 divided by 2. Okay. Now for the top. Now I know the secret. The top, it turns out, and this is hard for me. It turns out that 512 is 64 times 9? No, 256, excuse me. Yeah. It's 250, let me write, okay, it's 256 times 2. 3 is 3. The 4th root over 8, just like it always was. The 4th root of 256 is 4. 4 times 4 times 4 times 4 is 256. Times the square root of 2 over 8. Well, 4 goes into 8 2 times. So, what's going on? Yeah, there should be another 4 here. 4th root. So we get the same answer. 3 times the 4th root of 2 over 2. But it was brutal. It was hard. We had 4th root of a large number. In the bottom, I just multiplied by the 4th radical of 2. But you had to know that 8 can be broken up. You realize that it makes the numbers much, much smaller. I can't stress that enough. I cannot stress this enough. If you had 7 over the 5th root of 108. Now, you should maybe find the prime factorization. 2 goes in there 54 times. 2 goes into 54 27 times. And you know, if you realize that's 3 cubed, you can stop there. If you don't, well, it's 9 times 3, and the 3's can be split up. So you get 2 squared to the 5th root of 2 squared times 3 cubed. That is, it's the 5th root of 2 times the 5th root of 2 times the 5th root of 3 times the 5th root of 3 times the 5th root of 3. A lot of writing but it makes your life easier. In fact, let's make it fourth root instead. And that one backwards. Anyways, make it the fourth root. That's the original problem. So all of these are fourth roots. Fourth. Fourth root is 3. If you can't read, well, I'll rewrite it, but if you can't read the 4s, they're there. I promise you they're there. So, this is the fourth root of 2 times the fourth root of 2 times the fourth root of 3 times. 3 in my mind. That could be 3. The fourth root is 3. Now, what do we multiply it by? Well, we want to multiply it by 1. Well, you need the fourth root of 2 4 times. I have it 2 times. So, I need it 2 more times. I need the fourth root of 3 4 times. I have it 3 times, so I just need it 1 more time. And if you multiply 2 times 2 is 4, times 3 is 12. The top is just the fourth root of 12. What's in this bracket right here is simply the number 1. I multiply the tops. I get 7 times the fourth root of 12. And in the bottom, fourth root of 2. 1, 2, 3, 4 times. That's 2 times the fourth root is 3. 4 times. That's 3. And there's my answer. 7 times the fourth root of 12 over 6. If you want, you might want to see if you can break down the fourth root of 12. 2 to the fourth is already 16. So no, you can't. Okay, and there's your answer. Let's try one more like this. It seems hard, but let me tell you, it's a lot harder if you multiply by the fourth root of 108 3 more times. Okay, that would be brutal to have done that. Okay, let's consider this problem. Suppose you have 8 divided by the cube root of 18. It really pays to look at the prime factorization, because 18 is large. You really do not want to do this. You don't want to do it this way. Oh, this is simple. I need 2 more cube roots of 18 to have a total of 3 of them. So the top will be 18 times 18. 324, I guess. I'd rather do 36 times 9. 324. Okay, now I agree that, well, the top is 8 times the cube root is 324, and the bottom is just 18. The problem is, finding the cube root of 324 is hard. Okay, we did all that work, but we're not even done yet. The fun really starts at this point. Figuring out what the cube root of 324 is, really simplifying it. You don't want to do this. So you do the prime factorization. 9 times 2. It's 3 squared times 2. So this is 8 over the cube root of 18. If the cube root of 18 is the cube root of 3 times the cube root of 3 times the cube root of 2. 3 times 3 times 2 is 18. Now I multiply by my 1. And I need 3 of things. I need 3. I have 1, 2 square cube roots is 3. I need 1 more of them. I have 1 cube root of 2. I need 2 more of them. 3 times 2 is 6, times 2 is 12. The top is just the cube root of 12. So 8 times that is just 8 times the cube root of 12. And in the bottom, cube root is 3 times itself 3 times is 3. Cube root of 2 times itself 2 times is 2. And 2 goes into 8 4 times. It's 4 times the cube root of 12 over 3. On the top, I guess we could have said this is 4 over 9. Now, what you'd have to know is, just let me cheat a little bit, please. What you have to know is that 324 is 27 times 12. And good luck figuring that out. Good luck in figuring that out. That's why I prefer to use smaller numbers. The cube root of 12 is cube root of 27 is 3. The cube root of 12 I don't know. So finishing the top on the bottom here, you have 4 times the cube root of 324, which is 3 times the cube root of 12 over 9. 3 goes into 9 3 times, and you get this answer, 4 cube root of 12 over 3. You don't want to do it that way. Even if you can't do it the way I'm doing it, try. Get as far as you can. Get partial credit. You don't want to do it the way it is on the top. You want to break down that denominator. Okay. Look at these. You remember that A take away B times A plus B? This is the conjugate of that. That's the conjugate of this. They only differ by the sign in the middle. The A gets squared minus, and the B gets squared. So for example, if you have 7 minus the square root of 5, 7 minus the square root of 5, you want to multiply this by 7 plus the square root of 5. Very easy to see that this is 44. The 7 is like the A above, there's the minus sign, and the square root of 5 is like the B. The same A plus the same B. So we're to get the 7 squared minus the square root of 5 squared. We're to get 49 minus 5. The square root of 5 squared is 5. It is not 25. You all know what to square to get 25. There's only one reason that you'll say 25, and that's because you know square root of 5 squared is 25. What you're messing up on is what I'm about to put in the bracket, that's not 5. I've never seen anyone say 5. You know, if you ask somebody, write down 5. Everyone, you know, I mean, maybe they wouldn't understand it, write that, or many people would write that. Nobody would write that down. Somebody say, just do me a favor, write down 5. I forgot how it looks. I forgot how it looks. You'd write that. Nobody would write that down. Because that's not 5. So when you square it, you do not get 25. Okay, so you need to know your formulas. You need to know the formulas. And this, now notice that what we ended up with was an integer. No radicals. We got an answer with no radicals. If you have 10 plus radical 2, what would you multiply this by to get no radicals? The answer would be the conjugate. If that's plus, I'm going to write minus. So you get 10 squared minus square root of 2 squared, which is 2. You get 98. Problem's done. Yeah, that's what happens when you multiply conjugates. You square stuff. And if there's radicals, the radicals cancel out. You have the square root of x minus the square root of y. You multiply by the conjugate. You get this squared, which is x, minus this squared, which is y. You need to know that formula at the very, very top. And since multiplication commutes, I could have made this plus and this minus, and it's still the same answer. Because I can switch the order. Instead of multiplying this by that, I can multiply that by this. Multiplication, you can switch. Again, you're not allowed to have radicals in the denominator as your final answer. So if you have 3 over the square root of 5 plus 1, this can't be the final answer. And the instructions say to simplify. So that means I want to change the way it looks. I don't want a radical in the bottom. So that means I'm going to multiply by 1. Use the conjugate. If the bottom is square root of 5 minus 1, the top has to be the same way. Now whatever you do, do not distribute. Do not distribute. The reason is, if the bottom happened to be 9, for example, the bottom happened to be 9, in this format, let me write it down here, in this form, you can see the cancellation going on. But if you had distributed, if you had 3 square root of 5 minus 3 over 9, now you don't see the 9 canceling. So that's why you don't distribute. That's why you don't distribute. Now, what is the bottom? Since we're multiplying conjugates, it's this squared, which is 5, minus this squared, which is 1, and that's 4. It's 3 times the square root of 5 minus 1 over 4. That's the final answer. You got 4 over the square root of 2 minus 7. Want to change the way it looks. Why is that? You don't want a square root in the bottom. So you multiply by 1. Now, if you wrote 8 over 8, I would put a check mark there. Because this number is equal to itself times 1. The only thing is that multiplying by 8 in the bottom isn't going to get rid of the radical. But nonetheless, if your equal sign is right, I can't say, nope, that's wrong. It's just the wrong representation of 1. You should put the conjugate. You should put radical 2 plus 7. Radical 2 plus 7. And the numerator will be 4 times radical 2 plus 7. Divided by multiplying conjugates. You get this squared minus that squared. That's negative 47 on the bottom. But I can put the negative on top. And then you should see if you can reduce the 4 and the 47. And in this case, you can. Let's consider another problem. Suppose you have the square root of r minus the square root of 2s, and you are dividing this by, it's a good thing, say the square root of r minus the square root of s. You want to get rid of the radicals in the bottom. If only you can square them. Because if you squared the square root of r, you get r. And if you square the square root of s, you get s. If only we can square them. Well, there's a way to square it. Multiply the bottom by square root of r plus the square root of s. But to make it equal to the other side, you can only multiply by 1. So I do the same to the top. And then the bottom becomes this squared minus this squared. And the top, well, that becomes r. That becomes the square root of rs minus the square root of 2rs. Now we multiply by this. Minus the square root of 2rs. Minus the square root of 2s times s. There's your answer. The only thing maybe, no big deal, is you can put the r minus s more in the center of the denominator. There it is. Okay, let's do one more. This one will be a little bit harder. But not much different. Suppose you have 4 over the square root of x plus 4 minus 3. You want to get rid of the radical. You don't want any square roots in the denominator. That means you want to change the way it looks, which means you multiply by 1. It's this minus that. So I write this plus that, top and bottom. That's what makes it 1. Okay, for the top, you get 4 times the square root of x plus 4 plus 3. And in the bottom, well, this is my a minus b, and here's a plus b. So you get a squared, which is x plus 4, minus b squared, which is 9. So you get 4 times the square root of x plus 4 plus 3 divided by x. You add 4 and you take away 9, you took away 5. And there's the answer. That completes this section. Good luck with it.